Hi everyone, this is Poornima Mahalinga working as an assistant professor in the Department of Tripling. In this video lecture series, today we are going to discuss about PN junction diodes. Come, let's go to the topic. So before going to the topic, we can see the definitions, basic definitions. First, what is PN junction diode? It is a semiconductor device which resists the conductance of conductors, and most device it is made up of germanium and silicons. And so what do you mean by doping? So doping is the process of adding impurities to the device to increase the flow of free current carrier charges. Next point, what do you mean by current carriers? The majority carriers are the predominantly carriers in the semiconductors, and if it is N-type, we are giving the arsenic, it is an electrons and negative, and it is P-type material, aluminum, then it is known as holes, and it is positive. Okay. Now, coming to recombination. What is recombinations? So the excess electrons flows back into their respective orbits and it limits the current flow. This is what the recombinations. Okay. Now, what is PN junction diode? Here we have seen the basic definitions before going to the topic. Now we are going to see what is PN junction diode. So PN junction diode, when P-type semiconductor is suitably joined to the N-type semiconductor, the contact surface is called as PN junction. So the contacting surface is also known as PN junction. Here we have the picture. Here we can see we have a P-type semiconductor and we have an N-type semiconductors. Here we can see we have an P-type semiconductor and we have N-type semiconductor, and with these two semiconductors joins and the contact surface is known as PN junction diode. This surface is known as PN junction diode. Okay. Now here next thing, what do you mean by N-type semiconductors? So here we know that we have two types of semiconductors. One is P-type and next one is N-types. So now we can see what is N-type semiconductor. When a small amount of pentavalent impurities is added to the pure semiconductors is known as N-type semiconductors. So here we are going with the pentavalent impurities. Here, what is it? Here we have seen this is the pentavalent impurity atoms, and we can see the free electrons, pentavalent impurities. Here we can see the more number of free electrons. So by adding more number of pentavalent impurities, we can gain more number of free electrons. If we have more number of free electrons, then it is known as N-type semiconductors. Now we are moving for P-type semiconductors. Here, P-type semiconductors, when a small amount of trivalent impurities is added to the pure form of semiconductor is known as P-type semiconductors. Okay. Here we have seen the holes. This is what trivalent impurities, and we are adding, then we are having more number of holes. If the number of holes are increases, then it is known as P-type semiconductor. Here, now we are coming for depletion region. Now we can see what happens here. P-type semiconductor, N-type semiconductors, it joins together and it forms a junction and the depletion layer is formed. Here first thing is the depletion layer form, and the PN junction is set up across the depletion layer. So this is what first the P-type semiconductor and N-type semiconductor and PN N-type, and the electrons, holes and migrate across the junctions, and finally the depletion layer is formed. And this is what the depletion region is also called as depletion layer and the depletion zone. Okay. Next, the combination of electrons and holes depleted the holes in the P regions and the electrons in the N region is known as PN junction, depletion region. Okay. Here the next is diode schematic diagram. This is the symbol of diode. This is symbol of diode. The diode is a compromise of anode and positive and side, and cathode as a negative side. Anode as a positive side and cathode as a negative side. But actually the current flows from negative to positive. Here the conventional current flows from negative to positive. Yes, the conventional current flows from negative to positive. As an easy way to remember, the cathode sounds like K, which is the same of cathode. So it sounds like K, and it is the shape of cathode C. Okay. Here, this is the picture of diode. This is the picture of PN junction diode. This is anode side, and this is what cathode side. Okay. Here, a small activity. So here we have a multiple choice question. The process by which the impurities are added is known as, here that you have 5 seconds. The answer is doping. The answer is the process by which the impurities are added to the pure form of semiconductors is called as doping. Okay. Here. Now coming to the next thing is biasing. So what do you mean by biasing? In relation to PN junction, there are 2 types of biasing. So one is forward biasing, next one is reverse biasing. One is forward and next one is reverse biasing. Now let's see the battery connections. Based on battery connections, how the biases are differentiated. The positive terminal of the battery, here the positive terminal of the battery is connected to the P region, and negative terminal of the battery is connected with the N region, is known as forward. It is known as in a forward bias mode. Here in reverse bias mode, so the negative terminal is connected with the P region, and the positive terminal is connected with N region. Then this mode of operation is known as reverse bias. And now we are going to see about the forward biasing. When the voltage is applied across the diode in such a way, the diode allows the current and the potential barrier reduce the diode is said to be known as forward bias. Here we can see the forward bias. When the positive is connected with P terminal and negative is connected with N terminal. So this is known as forward biasing. Here what happens is when we increases the supply, what happens is the depletion layer breakdown. Now in forward bias, what's happening? So no current flow until the barrier, potential barrier 0.35 germanium, and for silicon 0.7 for silicon, 0.7 for silicon. Okay, and then what happens? The curve linearly rises when the current increases with the increase in the forward bias. Okay. Then above 3 voltage, the majority carrier passes through the PN junction and the sufficient energies get into the lock of the energies. The next thing is, therefore, the forward current increases sharply. In this things happens in the forward bias. Here we can see what happens. Example 0.6, still 0.6, there is no current flow. There is a minimum amount of current flow. After 0.6, this breakdown, what happens? After breakdown, there is a drastic increase in current. We can see that. In positive half cycle, what happens? This depletion layer gets breakdown. Now, after 0.6, what happens? The breakdown occurs. This is a forward bias. In reverse bias, the opposite. In the reverse bias, it is opposite. Okay, here we can see the animation video. So before applying 0.6, if the depletion layer is increases, there is no current flow. If the depletion layer is decreases, there will be current flow. Okay, here we can see the animation video. And we have a small activity. So multiple choice question. The key voltage in cutoff of silicon diode is 0.7 volt. So for silicon, already I have told that this for silicon 0.7. Next, we are going to discuss about reverse bias. So reverse biasing, when the applied voltage across and the current potential barrier increase, the diode is said to be reverse bias. Here what happens, the negative terminal is connected with P type and the positive terminal is connected with N type. And then what happens, that this depletion layer gets increases and finally it breaks through. We can see what happens in reverse bias. So the junction resistance and potential barrier increases. If the resistance increases, automatically the current flow gets decreases. The current flow gets decreases. Here the next thing is, when the reverse voltage increases beyond the values called as breakdown voltages. Here the next is reverse current increases sharply. The next thing is above 25 reverse voltage, that destroys the junction permanently. So above 25. So if we reverse voltage, if we increase the reverse voltage, then the junction will be destroyed. The junction will be destroyed permanently, and we can't use this device. Okay, this is a major disadvantage. Here here we can see the reverse bias. See reverse bias. What happens for the depletion region? depletion region. What happens to the depletion region? It will be having minute amount of current flow, and for particular value, they'll be having minute amount of reverse current flow. That is a reverse current flow in microamps. The saturation is the next, the current flow is the reverse saturation currents. Here we can see minute amount of current flow. Here we can see the animation video. Okay. So now coming to the characteristics diagram. Here we can see the first forward bias characteristics. This is for germanium and this is for silicon. So the breakdown voltage for silicon is 0.7 and for germanium is 0.3. So this is the breakdown voltage. And here we can see the forward, this is your forward bias graph, and this is what your reverse bias graph, reverse voltage. Here it will be having a minute amount of reverse saturation current. After that, it breaks through. This breakdown is known as avalanche breakdown. This we can discuss in upcoming classes. Finally, we are moving to the advantages. So no film is necessary and occupies less space, and it is long life. And applications of diodes, where it is we are using it, is act as a rectifier, used in rectifiers, clippers, clampers, and reverse current protections and logic gates. In this, we are using the PN junction diodes. Here, finally, small activity. So the depletion region with PN junction is reduced when the junction is forward bias. When forward bias, the depletion region gets reduces. The depletion region gets reduces. Here we can see small animation video. Then we can end off this section.
PN junction. When a p-type semiconductor is suitably joined to n-type semiconductor, the contact surface is called PN junction. Consider two types of materials, one p-type and the other n-type.
P-type and n-type, the diagram. We can see in the diagram. It is in p-type. And we have majority holes. And right side is right side semiconductors.
And free.
We have more free electrons in the n-type. So when this is what depletion layer.
The free electrons to diffuse p side across the junction.
See here, we are forming the depletion layer junction.
Positive donor ions spill on
Yeah.
the side of the junction. At the same time, the free electrons cross the junction and uncover this. Therefore, when is sufficient, it is
Here we have no this. So what happens here is the layer formation, the formation of PN junction
n-type
semiconductors.
Thus, a barrier is set up
Is
against
the barrier.
of charge carrier, that is, holes and electrons. This is called potential barrier.
Potential barrier of the junction barrier.
In which no free electrons or holes are available is called the depletion layer.
Okay, I hope everyone will be understand what is PN junction and what is biasing and what are the types of biasing, that is a forward bias and reverse bias, and how the working of forward and reverse bias, and where this diode is used, and what are the advantages of this diode. With some other topic we can see in next video lecture series. Thank you so much.